Hi everybody, welcome to another video in this week math section 6.1, the basics of counting. So in this section we study a different way we count, how many ways to do some certain things. The first one is the product rule. The product rule says that if a procedure can be broken down into sequence of tasks, two tasks, there are n1 way to do the first task and n2 ways to do the second task. Then there are n1 times n2 ways to do the procedure. The question is, how many bit string of length 8 are there? So, a bit is either have the values of 0 or 1, and if we have 8 of them, then 8. So each of the bit can either take values of 0 or 1. So there are two ways to select. The bit can be two ways. A bit can be so 1, 2, 3, 4, 5, 6, 7, and 8. So just 2 times 2, 8 times. So that's 2 to the 8, which is 256. So a big string of length 8 have 256 different values. Or that's called 1 byte, by the way. How many different license plates can be made if each plate contains a sequence of 3 uppercase English letters, followed by 3 digits. English letter, there are 26 in the alphabet. So that much. And it's the numbers 0 to 9, then 10 each. So multiply straight across, we have 26 times 1,000. (26 cubed) times 1,000, or 10 cubed. We have that much. Right, so that much variety in the license plates. Right, next. The North American numbering plan specify that telephone numbers consist of 10 digits and 3 area code, 3 for the office code, and the 4 digits for the station code. Right, so like this. And X can be anything from 0 to 9, and start from 2 to 9, so there is no 0 and 1, and Y is 0 and 1. Right. The old plan used in the 1960s, the format was NYX and NX. Right. So pretty much it starts from a number n. In this format, how many possible numbers we can have. Right, so just say NYX, NNX, and XXX. Right, N can be anywhere from 2 to 9, so there's 8 options. Y can be 0, 1, so there's only 2, and X can be anything, so that's 10. Right, that's the first set. Next, N and X, so be 8 times 8, and then X, 10, and then XXXX, so that would be 10. Right. Right. So the purpose of that, there's 2 options here. Is sometimes it's, as you see, if you wonder, the area code for Dallas is 214, and if you check every big city in the US, the number tend to be small, because way back in those days, the telephone is back in the dial, and the smaller number, the faster you dial the numbers. So the big city more often, so they choose the smaller number so they can dial faster, right? So multiply all of this, we have how many possible phone numbers we have in the old system. And then 8 times 10, and then 10 to the 4th. Right, so we have that much. Right, so that's the old system. Now this is the North American, so the Canada and US both using them, I think. So in that case, the population of both countries, let's say about 400 millions, and so that's still enough. But of course, we're not talking about people. A person can have more than one phone, and we're talking about business and other things. So this might not be enough. So that's why they go to the new plan of NXX, NXX, and XXXX. So the N could be anywhere from 2 to 9, so there's 8 options. And with that, and then times also 8, then 10, 10, and then 10 to the 4th. Yeah, to just multiply. So 8, so pretty much 800 times 800, or 800 square, then times 10 to the 4th. Right, so like that. 6, 4, how many 0 are there? 1, 2, okay, we just count. 1, 2, 3, 4, 5, 6, 7, 8. Right, so that be A0. Because 10 to the 4th, 10 to the 8th. So that's how much we have. 6 billions. So in that case, I think that we have more possible number. Of course, as the population increase and later on we might have more and more numbers, so the plan will change or may change later. Right. So of course, what we've been doing here is the product rule of different state, more than one state. Now, the product rule in terms of sets. If we have a finite set, then the number of elements is the Cartesian product. So pretty much just that. So like all the pairs, just going to do that. Right, the absolute values, it's not really absolute values, it's how many we have in this set. So the number of element of the Cartesian product given by the product of the number in each set. Right, so that is the product rule. Next, we have the sum rule or addition rule. The sum rule can be phrased in terms of set. Union of A or B is equal to A plus B as long as A and B have nothing in common. Later on we'll see, actually not much later, that they may not have they may not be, I should say they should have something in common or not. We should have to worry about that. In this case, they have nothing in common. Alright, look at this example. Suppose that a statement label in a programming language can be either a single letter or a letter followed by a digit. So if we just have a single letter, there are 26 ways to select it. And if we have a single and a digit, single digits follow a letter, so you have 26 for the letter and 10 for the digit. That's 260. Right, the difference between the sum rule and the product rule is that in the product rule there's only one case and we select different stage of the problem. In the sum rule there are different cases, so we just add those cases together, like 26 for this case and 260 on that case. So we have 260 plus 26, that is 286 different labels, possible labels. Right, just like that. Next, each user on a computer system has a password which is a 6 to 8 character long, and which each character is an upper letter or a digit. Right, so uppercase letter, so there are 26 of them, and the digit be 10, so 36 total. But each password must contain at least one digit. How many possible passwords are there? Alright, now remember we talked about the sum rule is for the addition of different cases. This product rule is just one case, multiply every stage in that case. So in this problem we have the case of 6 to 8 digits, 6 to 8 character long. So if we have 6 character long, that uppercase and the digits, so that will be 36 total, and then 6 spot, so each of them you have 36 choice. But we must have at least one digit. Now this is difficult if we have to count that. However, it is very easy to count when we don't have any digits. If we have only 26 letters, so 26 is no digit at all, raised to the 6. So you have 36 cases of maybe letter or digit mixed up together. Subtract 26, that is no digits. If you subtract that out, we have to have at least one digit. So it is perfectly fine to have all 6 digits, but we cannot have 6 letters, right? So we have 36 to the 6, there's 6 spot, could be number or letters, doesn't matter, but have to subtract the case, subtract the scenarios where we have all letters. 26 will be meaning all letters, to the 6 meaning all 6 letters, and so just do that. And then for the 7 character long, just raise to the 7 because there was 7 place, and then subtract the case when the all letters, and then 8 character long. Just do that. And now this is the sum rule because we just have different number for each case, so just going to add all of them up. That gives us the total number of the string that have the password that have this characteristic, right? So 36 to the 6 minus 26 to the 6 plus 36 to the 7 minus 26 to the 7, 36 to the 8 minus 26 to the 8. So we have that. Right. 2.68 times 10 to the 12. Right. This calculator will not give you all the digits, so we just have to stick with that. Right. Next we have the subtraction rule. Right. The subtraction rule, if a task can be done either N1, N1, N2, and the first task is in N1 ways, the second task is in N2 ways. So the total number is the total N1 plus N2 and minus the overlapping of the two. Right. Here's some example. how many bit string length uh, of 8. That start with 1 and end with 0. So the key is OR. Right. Total, how many we have? Of course, we can either do that. So let's say it. We have the number of, let's say it, start with 1. Let's say that set is A and end with 2 bits 0 0. That set is B. Right? So what we want is A or B. Right? Either start with 1 or end with 0 0. It's either start with 1 plus B minus A intersect B. Right. So A, if we start with 1, we only have one option, that, and then it's followed by 7. Digit can be anywhere from 0 to 1. So the rest is going to be 2 to the 7. So for A, we have 128 different weight. Right? Because 2 to 7 is 8. So the first one had to be 1. After that, doesn't matter. It's going to be 0 or 1, 0 or 1, 7 times. So 2 to 7, 128. The first one has to be 1. Right, for B, the first 6 doesn't have to problem, but we have to end up with 0 0, and there's only one choice for that. So that's 2 to the 6. Or 32. This is 2 to 7. Okay. Yeah. For the 6th part, you can choose anywhere from 0 to 1. So 0 1 for the first one, 0 1 on the second one, for 6 times. So 2 to the 6th power. The last 2 has to be 1. Had to be 0 0. Therefore, we only have one option for that. Now 8 intersect B. So have 1 and then 0 0 at the end. So I have one option for 1 from the beginning. Only one option, 0 0 at the end. At the middle though, there are 5 digits left, which can be anywhere from 0 to 1. So we have only 2 to the 5th. Right? So the middle can be 0 or 1 5 times. 2 to the 5th, 32. So you have 128 plus 64 minus 32. And that gives us 160 different ways of selecting of the string can be. Division rule. The division rule. Right. If there are n over d ways to do a task, it can be done using the precision. It can be carried out n ways, and for every way w, exactly d of the n way correspond to way of w. Restated in the terms of set. If finally set A is a union of n pairwise disjoint subset, each with d element, and n equal to A divided by d, the number of elements in A divided by d. In terms of function, if a function from A to B where both are finite set, and for every value y in B there exactly d values x corresponding to that, then B is equal to element of B equal to element of A divided by d. Alright, let's look at this example. How many ways are there to sit 4 people around in a circular table, and each 2 settings are considered the same when each person have the same left or right neighbor. Right, so let's say you have sitting on the table, right? I'm going to drop 4 from. Right. Suppose on the table, this 4 position, you can choose anything. The first one, you can choose one of the 4 people. So there are 4. And the next one, excluding him or that person, there's 3 left. Excluding those 2, there's 2 left, and there's 1. So 4 options to choose this, a person to put on this sheet, and then 3 on the next one, 2, and then 1. So that 1 times 2 times 3 times 4, that's 24. Right? This is not the actual numbers. This is just how many it is seated. Now, so that's 24. But remember, this is a circular table. You can certainly rotate. In that case, this is the same seating. We just rotate the desk. Because the way we define that is each person at the same left and right neighbor is considered the same. Because when we rotate, that's still the same. People sit on the left and the right. So, in that case, even though the first spot you can choose 4, and the next spot you can choose 3, and then 2, and then 1 left. Remember, we can rotate. So that whatever you choose on that place, if you rotate here, there will be another position. Rotate here, there another one, and rotate here, there another one. Bottom line is there's 24 total, but we have to divide by 4. So that's only 6. Because there, this is completely different. This is not the cases. Let's say you put person A, B, C, D here. That got the same as A, B, C, D. The same orientation, just clockwise in that order. Of course, you can, don't want to put A there, you can put A here and go clockwise. So all 3 of these are the same. So that's why we can start A here, A here, A here, or A here. So there are 4 cases for that. So 24 divided by 4 is 6. 6 different ways. Right. Finally, in this section, we also study about tree diagram. A tree diagram can help us to visualize and then count how many we have. For example, let's say you design a t-shirt like that, and there are 5 different sizes: S, M, small, medium, large, extra large, 2X large. So there are 5 options there. Now the color scheme. Each size comes in 4 colors: white, red, green, and black. So therefore each, except for extra large, can only go with red, green, black. And in XXL, only green and black. Right. So S, there are 4 different colors: white, red, green, and black. Same thing for medium. And large also have 4. And extra large, there are only 3. Red, green, and black, only 3. And then extra large, only 2, green and black. So in that case, we list a tree diagram like that, and after that we just can count the end of the tree. So 1, 2, 3, 4, 4, that's 12, and 5, so that's 17 different ways. So the store have to store at least 17 t-shirts, one for each kind, so that we have all the size and all the colors. Yeah, need to stock have the each size and each color available. So 5, and each one have different cases. Then we just count the end of the branch. There's 17 of them, so that 17 different type of shirt that the bookstore have to have. Alright, with that we finish section 6.1. Thank you for watching. See you in another video in this week, man.